infections are passed on between or to humans. And the reason that's important is if you understand the route of transmission, then you can work out a way of combating the infection, stopping it spreading. And of course, these are very different depending which ones you're dealing with. So in the last lecture in this series, I talked about vector-borne diseases, insects and arachnids, that actually you can by interfering with the insects, you can stop the transmission of the infection. Today I'm going to be talking about one of the commonest routes of transmission, and that's the oral route, almost entirely by food, water, and other drinks. A point I will make repeatedly through these series is that for almost all infections, there is a dominant route, and sometimes only a single route, by which they're transmitted. There may be some secondary routes as well, so they may use more than one of these. There's usually a dominant route, and that is the one you need to tackle if you want to reduce the infection. Now, from the point of view of the infecting virus, bacteria, parasite, the oral route is potentially a very good one for an infection to enter the body, and therefore multiple viruses and bacteria have evolved to use it. And the reasons for this are pretty straightforward. Water and food are essential. You can't avoid taking things in orally. It doesn't actually, from the infection's point of view, require the person or the animal doing the infecting to meet the infected person. That's in contrast to some of the other routes I'll talk about later in the series. So, for example, with cholera, which is passed on through water, go on to more of that later, you could be quite a long way downstream of the person who does the infecting through the water source. And with several of these infections, people are often infected for long periods, years potentially, and therefore can infect people over quite a long period of time. Now, within this broad category of infections by the oral route, there are several particular routes which infections use. And again, it's important to work out which of them is the principal one, because that way you can actually target the countermeasures to the most effective way. The first is waterborne, actually through drinking water or its products. Second, milk and milk products and eggs, so dairy products. Then, and there'll be quite a bit of this in this talk, the various ways by which either human feces or animal feces can contaminate food and water, particularly food, and that's actually very important. The key really to controlling many of these is keeping feces and food separate. Sounds obvious to say, it's actually surprisingly more difficult to do. And then there are a variety of particularly parasites of animals and fish, which humans are a central host, but they have a very complicated life cycle, where they switch between the animal and the human and back again. And then finally, there are some infections where humans are accidentally infected. They're what's called a dead-end host. They can't be transmitted by humans, but they're transmitted to us by animals, in a sense, without being part of the life cycle. And I'll go through examples.
Yes, but coronavirus didn't come from bats.
It's a varied group
it's not how we got it, it's an RNA.
That are passed on
made.
orally.
But yeah, the rest is absolutely
Now,
true.
doing it slightly differently, if you know that transmission is via the oral route, there are some broad, clear countermeasures, and that really depends on where they come from. If the infection is from humans, then hygiene, especially hand washing after defecation, sanitation, which is feces disposal and clean water, and cooking or washing and boiling things is the key, and you need to use some combination of these. If it's from animals or poultry,
boil water and just pour it on the kitchen sides and that, or I don't do that, but
animal husbandry and agricultural practices, but you also need to use hand washing when cooking and cooking meat. So those two come up repeatedly. And if it's from fish, then cooking and freezing are essential. So there are a variety of things you can do.
Yeah, like frozen meats you have to buy.
As countermeasures. But as I'll come on to, the majority of the ways that we deal with this are in fact not medical interventions in the ordinary sense. Because for the oral route of infection, engineers farmers, food handlers and cooks are far more important to interrupting the transmission of infection than doctors. And that's been true for millennia. And there are some of the ways that they can contribute. Let's start off with the engineers. Clean water technology has been central to keeping infections, particularly waterborne infections, down over centuries. And I've given an example here of the Pont de Garde in France, Roman aqueduct taking water from one place to another. Sewers are really essential. We don't think
yeah, but
really
we
much about
have,
them,
oh, look at our water from the tap,
pre-sewer
like recycled
era,
sewer water.
it was much more common that human feces would get into water and into food and therefore lead to chains of transmission. And cooking and chilling and freezing technology, refrigeration and cookers of different sorts, are also essential. So that's some of the things that engineers have contributed. And then on the food handling side, hygienic animal husbandry has really changed the way in which many infections are passed between animals and therefore on to humans. Identifying and isolating diseased animals is very important so they don't get into the food chain, and maintaining a hygienic and cooled food chain all the way from field to fork. So these are the kinds of areas which have led to a very significant improvement in infections passed on by the oral route. I'll start off with water. And here I think it's important to use a rather, I'm going to use a rather old-fashioned, I think,